Now we will try to determine the household maximization model without the theoretical approach, and we will try to look after the model only with the help of mathematical derivation of the model. Now how can we mathematically derive the model? At first we have to find out the value function. Now what is the value function? Value function is v, that is basically u of ct. U of ct is the value function here now, and u of ct is for the entire life period. That means this value function is basically an utility function, and utility function for the entire life period starting from 0 to capital T. Capital T is the time period in which, or till that time period, we are going to live. So this is basically our value function. Now by getting this value function, we have to find out a constraint by which we will do the optimization of this value function. Now what is our constraint? We know that Ct, that is the consumption of tth period, and if we take that consumption for the entire life, then it becomes summation Ct, summation where t starts from 0 to capital T, and it goes on, and this Ct is less than equals to our asset income, that is A0, that is the initial wealth or initial asset, and our actual total income of our entire life period, or total income for our labor, that is basically our labor income. So that becomes summation yt, where t starts from 0 and t goes to up to capital T. So this is basically our constant function. This is basically in the form of inequality. That means our total consumption, this is our total consumption, this can be either equal to our total income. This is our total income, this is A0 is our initial wealth, and this is our income from the entire life. So A0 plus this income of our entire life means our total income. So this total income is greater than our consumption, or it can be equal to our consumption. So this is the inequality form. But if we have to form, or if we have to struct the constant, then we have to take the equality form. Then we can write that summation Ct is equal to A0 plus summation yt. So this is basically our constant form. We have to take it as in the form of equal to 0. So now Ct, summation Ct, if we take the equality form and if we take it as in the form of 0, then it will become A0 minus A0 plus summation yt minus summation Ct, where in each of the cases this small t belongs, or small t goes up to on to capital T, small t goes up to on to capital T. Now this is our constant form, and it is equal to 0 as we have derived it from the earlier equation. Now what is our optimization? What is the function that we have to optimize? If we take the function in the name of L, then that function is now equal to summation u of Ct plus lambda A0 plus summation yt minus summation Ct, that is our constraint. So this is our form, or this is our Lagrange form, and we will try to do the derivative of this function. Then that we will find the marginal utility. So what is basically the marginal utility? The marginal utility, okay, at first for going to the marginal utility, we have to do the derivative of this function with respect to Ct. So if we do the partial derivative of this function with respect to Ct, then what will we get? We will get u dash Ct plus lambda, and in the as per the first order condition it will be equal to 0. So now it has become u dash Ct is equal to lambda. That means marginal utility is constant. As lambda is constant and marginal utility u dash ct is marginal utility, so marginal utility is constant. So we can write from here that marginal utility is constant. Similarly, if we see the previous slide, then we have already done the partial derivative of the function with respect to ct. Now if we do the partial derivative of the function with respect to lambda, then we will arrive or we will go to the function again. Let's see it. If we go to the function, then what will happen? Suppose the partial derivative of the function L with respect to lambda, then we will obtain this part a0 plus summation yt minus summation ct. This part will be obtained, so we will get a0 plus summation ct minus summation plus summation yt minus summation ct. So this will be plus summation yt minus summation ct. So this is our second. We have made the partial derivative of the function with respect to lambda and obtained this. This is equal to 0. So by this we can say that summation ct is equal to a0 plus yt. We can easily say this. Now if we want to remove this summation from this part of this equation, then we can easily multiply this ct with t, capital T. Then the summation can be moved on and we will get a0 plus yt. Now what will happen here? This ct will be equal to 1 by t into a0 plus yt. That means in consumption of all the periods are same. Consumption in one period is same to consumption in two period, is same to consumption in third period, and it goes up to same as consumption in tth period. So what are the two optimality conditions that we have obtained from here? So the optimality condition that we have obtained, the first optimality condition was that the marginal utility was constant. In this place we have obtained this u dash ct was equal to lambda. This is the first optimality condition in which we have obtained that the marginal utility is equal to constant. So that is our first optimality condition, that mu is constant. And what was our second optimality condition that we have obtained? The second optimality conditions that we have obtained is that consumption in all the periods are same. Consumption in all the periods are same. So we can write it here that consumption in all periods are same. Now these are our two optimality conditions. Now we will take the flow budget identity. What is the flow budget identity? Now flow budget identity can be written as the current asset form. What is our current asset? Current asset is suppose written as AT. Now current asset is basically nothing but our AT minus 1. What is AT minus 1? AT minus 1 is our previous asset. So previous asset plus our current income minus our current consumption, that is our current asset. So this form is basically the flow budget identity. Now you will take the we will try to optimize the value function. What was the value function? Value function was u of ct. It was in the form of summation also, that t is equal to 1 to t. That is the value function. Now value function, we have to do the optimization of this value function with respect to this flow budget identity. So what we will do here, we will do the optimization. Suppose the function is L. Now here what will be the, at first we will write the value function, that is u of ct in the summation. and then we will write the constant, but here the constant will be written in the summation form, and the lambda is not constant here. It is basically a part of dynamic optimization, that's why lambda is not being constant here, and lambda is within the summation. And what is the constant is basically at plus yt minus ct minus at minus 1. As you can see from the previous slide, thus this was our constant. This was basically our constant. So we will take at on the right hand side and we will derive the constant as equal to 0, and we will put that constant in this equation of L. So basically we will do the derivative of this L with respect to Ct at first. What will be the value? The value will be u dash Ct is equal to minus with respect to Ct it is minus lambda t, right? Minus lambda t, that will be equal to 0. Okay, so what does it mean? It means basically that u dash Ct is equal to lambda t. Now what is u dash Ct? This u dash Ct is marginal utility. Okay, and what is lambda t? Marginal utility of money. Lambda t is basically marginal utility of money. So we may say that the marginal utility of the consumption is equal to marginal utility of money in t period. So marginal utility in t period is equal to marginal utility of money. Marginal utility of consumption in t period is equal to marginal utility of money in t period. Then we will do the derivative with respect to of the function with respect to ut. So in this derivation we will get lambda t plus 1 minus lambda t is equal to 0 as per the first order condition. So lambda t plus 1 will be equal to lambda t, that means marginal utility of money in t plus 1 period and marginal utility of money in t period, all are equal. So marginal utility of money are equal in all the periods, and in the next part we will try to differentiate this function L with respect to lambda t. Now what will we get? We will get the function lambda t, sorry, not lambda t, we will get the function at first. Let me look into the function at first. This is the function. If we do it the derivative with respect to lambda t, then we will get this entire part. So what are we getting here? At plus yt minus ct minus, so we are getting at plus yt minus ct minus at minus 1. This is the part that we are getting. Now lambda t is equal to lambda t plus 1, that means marginal utility of money in t period is equal to marginal utility of money in t plus 1 period. That means marginal utility of money are equal in all the periods. So we may say that lambda t is equal to lambda t plus 1 is equal to lambda, because marginal utility of money in all periods are same. So we may say that u dash ct, that was equal to lambda t. As per this part of this equation we have derived that u dash ct was equal to lambda t, right? So now we can put u dash ct is equal to lambda, because lambda t and lambda t plus 1 and lambda t all are equal, all is constant. So this is obtained from here. Now we will try to do, or we will basically derive the risk aversion consumption function. What is risk aversion consumption function? Okay, now risk aversion consumption function is basically utility function of consumption with in which we may write that C T 1 minus theta divided by 1 minus theta. Now this is our risk aversion function, risk aversion utility function or risk aversion utility function of consumption. This theta is the risk aversion parameter and it is greater than 0 or it is positive. Now if we do the derivative of this risk aversion function with respect to Ct, then what will we obtain? We will obtain u dash Ct, and u dash Ct is nothing but 1 minus theta. Now we are doing the derivative with respect to theta basically, that's why we are obtaining with respect to Ct, sorry, we are doing the derivative with respect to Ct, that is that's why we are obtaining u dash Ct, that will be equal to 1 minus theta into Ct minus theta divided by 1 minus theta. Now 1 minus theta and 1 minus theta will be cut down, so we are getting Ct to the power minus theta. So what have we obtained? We have obtained that u dash Ct is equal to Ct to the power minus theta. I am writing it again. U dash Ct is equal to Ct to the power minus theta, that we have obtained here. Now u dash Ct is nothing but the marginal utility, that is equal to Ct minus theta. Now we will take the summation of this entire consumption of the entire life period, but while we are doing or while we are taking the summation of this entire period, then we have to take a discount of this consumption. So for taking the discount, we will divide it by 1 by 1 plus rho to the power t. Here it is not actually, let me write it again. So here it is, basically we have 1 plus rho to the power t and multiplied by, we have 1 plus rho to the power t, and this is multiplied by Ct to the power minus theta. This is basically our marginal utility has become after discounting it by 1 plus rho to the power t, where rho is the subjective discount rate. What is rho? Rho is basically the subjective discount rate. Now similarly, if we go to the next approach in which we will try to take this is the marginal utility of t period. Now marginal utility of t plus 1 period, what will be the marginal utility for t plus 1 period? Marginal utility for t plus 1 period, I will just substitute this function with in the place of t I will just write t plus 1, then it will become the marginal utility of t plus 1 period. So what is marginal utility of t plus 1 period? This marginal utility of t plus 1 period has now become 1 by 1 plus rho to the power t plus 1 into Ct plus 1 minus to the power minus theta. This has now become marginal utility of t plus 1 period. And as we know per the optimality condition that marginal utility of t period, that is this, and marginal utility of t plus 1 period, that is this function, are equal, because marginal utility in t period and marginal utility of t plus 1 period both are equal. Now as marginal utility of t period and marginal utility of t period t plus 1 period both are same, so marginal utility of t period and marginal utility of t plus 1 period both are same. So we will try to write the marginal utility of t period at first. What was the marginal utility of t period? This was the marginal utility of t period, right? So we have to write this 1 plus 1 by 1 plus rho to the power t into c to the power minus theta. So this has become now summation 1 by 1 plus rho to the power t into c to the power minus ct to the power minus theta. That will be equal to summation 1 by 1 plus rho to the power t into ct to the power minus theta. Now we may write it without summation also, that 1 by 1 plus rho to the power t is equal to into ct to the power minus theta is equal to 1 by 1 plus rho to the power t into t plus 1 1 by 1 plus t to the power into ct plus 1 minus theta. Now so this is the present or t period consumption, this is t plus 1 period consumption. So this is supposed to be discounted, this t plus 1 period consumption is supposed to be discounted. So we have to discount the next period or t plus 1 period consumption. T period consumption will remain same, so this will remain same, but the next period, that is t plus 1 period consumption, is supposed to be discounted by 1 plus r, and we have to multiply 1 plus r to give a discount to the t period consumption. So this has now become this. We have just multiplied it with respect t 1 plus r to give it a discount. Now next we have to find out what will be the value of ct by ct plus 1. So we are going to get the value of, at first we have to understand this what will be the value of ct by ct plus 1. So we have to do a derivative, do a integration for that. That is not supposed to be required for the model. We will just write the value after doing the integration. So ct by ct plus 1 will be equal to 1 plus r divided by 1 plus rho. Actually this will be a little bit I feel I have made a wrong statement here. This is little bit wrong. This is ct plus 1 is supposed to and divided by ct is supposed to be 1 plus r divided by 1 plus rho, and this is basically theta to the power theta. So ct plus 1 by ct to the power theta. Now let us assume that theta is equal to 1. So if theta is equal to 1, so we are getting ct plus 1 by ct is equal to 1 plus r divided by 1 plus rho. Now let me write the equation again. Ct plus 1 by ct is equal to 1 plus r by 1 plus rho. Now if r is greater than rho, then if r is greater than rho, then we are getting ct plus 1 is greater than ct. That means consumption of the future period or consumption of the t plus 1 period will be more than the consumption of current period. If r is smaller than rho, then we are getting from this equation that ct plus 1 is less than ct. That means current period consumption, that is t period consumption, is more than the future period consumption. So current period consumption is greater. So this is the household maximization model. We have to find out the value of r and p, and if r and p value are given, r and rho, if r and rho value are given, then we can find out that which consumption is going to be more in the consumer's life, whether it is the present period consumption or future period consumption.